Here's a typical physics problem that you would find using quadratic equations. In this case, we have an a value of -16, so this parabola is going to show a maximum point. We are required to find how long this rock is in the air, and part B, how high is the rock after 2 seconds, and thirdly, what was the maximum height reached by the rock. To find how long it's been in the air, we have to assume that it started at ground zero, went up into the air, and then came back down and landed at ground zero. So we're looking for the 2 points at time t that will give us when the height was 0. The easiest way to solve this quadratic equation is to use factoring. Here I factored out a -16t. Be careful with your negative signs here. Always expand to check. H of t will become 0 when one of the factors becomes 0. In this case, t could be 0 or t minus 10 could be 0. In this case, it was at ground 0 at t equals 0 and at t equals 10 seconds. So therefore, the time in the air was 10 seconds. Let's use GeoGebra to solve the problem. I've entered the equation and rescaled the axes to show the graph. I can see that my intercepts at the x-axis are 0 and 10. It confirms my answer. The axis of symmetry is halfway between 0 and 10, or at t equals 5 seconds. I've graphed the line t equals 5, and on this axis of symmetry is the vertex. I substitute at t equals 5 to see what the value will be, but I can also read it off the graph. It is 400. To find how high the rock is after 2 seconds, we can graph the x equals 2 line, or time equals 2. So what I've done is I graphed x equals 2, and it becomes a vertical line, and I look for the point where the two lines cross. In other words, where the parabola crosses the x equals 2 line. It looks like the line x equals 2 and the parabola cross at about y equals 250 feet, but I'm going to use algebra to check. So the exact answer would be 256 feet. The end of this video will show the algebraic solutions for parts B and C. Make sure you pause when you need to study it in more detail.